All right, hey everybody. Looks like we are on defining rigid transformations. Um, Slide 6. Well, basically, a rigid transformation is, um, well, anything except a dilation. Um, it can be a reflection, a rotation, a translation, a combo of those. Maybe a rotation and then a reflection, or a translation and then a rotation and then a reflection. Um, because they don't increase or decrease in size. The minute that it changes sizes, like a dilation, it's no longer a rigid transformation. Let's see what's going on here. All right, so like always, I open up my GeoGebra, which is on rotations. Oh, look at that. That's pretty cool. That'd make a great tattoo, wouldn't it? I bet if I slide this, it rotates around, hits every single one. All right, that's pretty cool. Woo! Use another one right here, though, to make it symmetric. That's just me. I gotta have things symmetric. Gotta be symmetry going on. All right, so let's see. Move the slider to rotate the original pre-image ABC so that at which angle does A prime, B prime, C prime coincide with all the others? Okay. Well, let's see. Well, for it to be back onto itself, so ABC to lay on top of ABC, that would be a 0-degree turn because it has to stay on top of itself. Also 360. So 0 and 360. But since I haven't turned it yet, I'm going to say a 0-degree angle. To DEF, well, let's see. 45 degrees. For GHI, another 45 maybe. Nope, 115. And to JKL, up 210. That wasn't too bad. Easy breezy. All right, question 2. All right, so create a circle with center P that passes through A. All right, let's do that first. Let me go back. I need a circle with center P that passes through A. So I'm going to come here to the circle icon, and I'm going to select circle with center through point. I'm going to click on P, which is my center. Then I'm going to click on A. Well, I notice that it hits D, G, and J. That's because when I rotate this triangle around, it landed on D, it landed on G, and it landed on J. All right, create 2 more circles passing through B and the other through C. Okay, so P to B, P to C. These are called concentric circles, by the way. So if you're ever going to target and you see the bullseye looking thing, or of course bullseye, like if you're shooting archery or whatnot, throwing darts, these are all concentric circles because they all have the same center, just different radii. All right, so what I've got to do here, use the slider again to rotate the triangle A prime, B prime, C prime. If the triangle rotates, what do you observe with respect to the circles you made? Well, they all remain on the same circle, I'll tell you that now. So A will remain on this bottom circle because I've already said that. B will hit E, H, and K. They'll stay on that circle. And C here will hit F, I, and L. It's going to stay on that circle. So just those points stay on the circles respectively. Remain on their circles respectively. If you don't understand what that means, it means just, hey, I'm talking about the A, I'm talking about the B, I'm talking about the C separately. So A would remain on its circle, and B would remain on its circle, and C would remain on its circle. So one word respectively, which I didn't spell right, and that just figures. Now I fix that. Respectively, I'm talking about each of them separately. And you guys are going to find I'm not a great speller, so hey, there's a reason why I'm a math teacher. And it's not for my spelling. All right, question 3. Measure the angles of triangle ABC, then measures A prime, B prime, C prime, and when it coincides for the other. Okay, well, they're going to stay the same, I'll tell you that now. Because I'm not making the triangle bigger or smaller. Remember, this is not a dilation. So I am not changing the size of the triangle, so they're all going to remain the same. So once I find one of them, I actually have them all. So I need to find angle A, angle B, angle C. Remember this is the angle icon. You're going to select angle. Now to find measures of angles inside a figure, you got to go in a clockwise motion. So you got to go to the right. So to find A, I got to click C, A, B. Uh-oh, what happened? It didn't go through? What's going on here? C, A, B, B, C, A. Oh, it's not doing what I want it to do. What's going on here? Maybe if I get rid of all of this stuff, it'll let me do it. I don't know. Oh, I didn't have my triangle on top of itself. That's what it was. C, A, B. There we go. 45. A, B, C, and B, C, A. Uh-oh, something didn't click. B, C, A. Undo. All right, B, C, A. Well, let's do that back. Come on, click B. There we go. C, A, A. Now you see I have technical difficulties myself. Hang on a second, you guys. Let me pause this for a second. All right, so let's see. Back to it. So 45 degree, 100 and, where was I? 108 basically, and what was that? 27 basically. Okay. All right, so B, again, that's the letter in the middle, so that was going to be our 108. So E would be 108, H should be 108, K would be 108. Remember, they're all the same. This is a rigid motion, so it didn't change sizes. C was the 27. So 27, 27, 27. And then angle A, that was the 45, I believe. So D is 45, G is 45, and J is 45. Okay, there you go. All right, question number 4. How do the measures of the angles compare? Well, they don't change. They don't compare. They don't change. It's a 1-to-1 ratio. They map back onto itself. The only time it would actually change is if it was a dilation. Dilations change. These do not. So the measures of the angles do not change and the sides do not change. The measures of the angles do not change. The measures of the sides do not change. Only in a dilation would they change, you guys. All right, question number 5. Looks like we're finding length. Well, I just said they don't change, so we all know they're going to be the same. So we're going to find the measures of the sides of the triangle and the measures of the lengths of the new ones. They're not going to change. So once you've got one, you've got them all. All right, well, that's fine. I can still do it. All right, so let's see. I'm going to go easy route. I'm going to go up here to the angle, but I'm going to select distance and length. I'm going to select AB, BC, and AC. I'm going to move those so you guys can see them better. So 3 was the bottom one. There we go. All right, so all of these A, B, D, E, G, H, J, K, they're all going to be 1.41. B, C, E, F, H, I, and K, L, they're all going to be 2.24. And the biggest one, all going to be 3. So make it easy on ourselves. 1.41, 1.41, 1.41, 1.41. All right, so BC, that was 2.24, 2.24. And when I move it, it's going to stay 2.24 on all the other 3 triangles. The last one was 3, and when I rotate, it just stays 3. Again, the only reason it would change is if it's a dilation. And these are not dilations. These are rigid motions, whether it's a reflection, rotation, or translation. They're all going to stay the same. All right, so how do you measure the side lengths of ABC compared to those? coincide with the other three triangles. So, again, they are equal, so they do not change as it rotates. These sides do not change measure as the figure rotates. Self-evaluations of 5. All right, you guys. So that was slide 6 of defining rigid transformations. Basically, what you need is, I don't care if it's a reflection, rotation, or translation, angles and sides aren't going to change unless it dilates. All right, that's it.